So imagine that this would be CO2, and we could capture that directly with these kind of devices. This is what we call direct air capture, and it's a technology to capture CO2 directly from the atmosphere. It's much needed to stay below the 2 degrees of global warming. Works sort of similar to a vacuum cleaner, but in the details it can get quite complex. So in this episode we will answer the question, how does direct air capture work? Hi, I'm Beatrix and I work at Carbyon. And in this Ask Carbyon series, we answer questions about capturing CO2 from the sky. Because we get many questions, we thought it's time to answer them. So together with experts, we explain how Carbyon is working on a solution. And in this episode,
this is the only way to be carbon negative.
Don't you produce more CO2 when you run the machine than we can capture?
The climate challenge should be a collaborating effort.
Vacuum cleaners can clean large particles and dust, but as we have learned in episode 1, CO2 is a gas. And that's not that easy to filter from air. So how can we do that? I thought it would be nice to explain this topic with some drawings. So I've held a small drawing competition among my colleagues to see who can make the best drawings. And there is a winner, it's Thomas, and he will help me with the answer. Before we dive into these technological details, can you maybe explain what is direct air capture?
Direct air capture is a technology that directly filters CO2 out of the air, similar to how trees do this, but we need to be faster and more of it. To do this, we bring CO2 in contact with a chemical substance that absorbs the CO2. Afterwards, we can remove the CO2 from the substance so that the process can be repeated again.
Can you maybe explain how does this technology work exactly?
The process works kind of like a vacuum cleaner. Air is sucked into the machine and goes into the reactor. This is the place where the filters with the chemical substance are placed. CO2 is captured by the filters, so clean air can be pushed out without CO2. After the filters are full, we close the reactor, and by heating it up, we are capable of removing the CO2.
If you're curious for more details, then don't forget to subscribe to the Carbyon channel to learn the answers to the other questions. We use energy to run our machine, so often we get the question, don't you produce more CO2 when you run the machine than we can capture?
We will run our machine solely on renewable energy. In this way, we can capture way more CO2 than what we produce to run the machine. This is the only way to be carbon negative.
There are only 420 CO2 parts per million air parts. Doesn't it make more sense to capture the CO2 directly at the exhaust pipe, where the concentration of CO2 is like 20 to 90%?
Indeed, it would be easier, but by blocking the CO2 out the exhaust pipe, we would just be carbon neutral, and more is needed to solve the climate problem. On one side, we have to remove the CO2 that was already released into the atmosphere in the previous decades. On the other front, we have to block the use of fossil fuels by blocking the emission of new CO2 into the atmosphere by finding alternatives to the fossil fuels.
So when I gave a presentation last week, someone asked me, when you would place your machines everywhere, would the industry not use it as an excuse to continue the use of fossil fuels?
It should not. The climate challenge should be a collaborating effort. On our side, the plan is to remove the CO2 that was already released into the atmosphere and stop the use of fossil fuels by finding alternatives for those. For example, by mixing clean hydrogen with the CO2 we capture, it is possible to build any fuel or chemicals for which fossil fuels are used right now. So CO2 from air is the missing link.
So it may sound like an easy solution, but why this is not done on a large scale yet, and how Carbyon is going to change that is what you will see in episode 3. I hope you liked this episode, and thank you for watching.